Okay, the last one here is probably new to you, and that's the binomial cube. And again, if you take the sum of terms cubed and you expand that out, it's going to be the first term cubed plus 3 times the first term squared times the second term plus 3 times the first term times the second term squared, and all times the second term cubed. And just like with the binomial square, you don't necessarily, oops, this should be a B. You don't necessarily need to have a separate form for the difference of terms cubed. Okay, but when you do take care of that, you cube the first term, it becomes a minus a squared b plus 3ab squared minus a b cubed. Again, the signs are going to take care of themselves, even if you just use that top form for any binomial cube. All right, so here's the way I would recommend you approach these problems. And I'll give you an alternate method to solve it, but this is the way I would approach it. Okay, what I would do is remember the expansion pattern, 1, 3, 3, 1. If you don't remember it, you can recreate Pascal's triangle very quickly. Okay, just building it from the sum of the diagonals until you see the 1, 3, 3, 1. And I would actually start with those coefficients, 1, 3, 3, 1. And then I take my first term, 3x, and that's going to be the base of my exponents as I move from left to right, starting with the highest power of 3, then 2, then 1, and then 0, just leave it out. And I can take my second base, 2, and I can start building that up, starting with the right to left, starting with the highest power of 3, 2, 1, 0. Okay, so here is my simplified expanded form. All I need to do is actually work through and completely expand or simplify these expressions. So 3 cubed is 27, x cubed. 3x quantity squared is equal to 9x squared. So convert that out. Combine what you have. 2 times 3 is 6. 6 times 9 is 54 x squared. If we square the 2, we get 4. 3 times 3 is 9 times 4 is 36x. And now cube the last term. 2 cubed gives you 8. And so that allows you to expand this out and rewrite your solution in standard form. All right, so try this one on your own. X minus 4 quantity cubed. All right, so let's take a look at the pattern. You recognize you have a binomial cube, so either build the pattern up or recall the pattern of coefficients as 1, 3, 3, 1. Okay, plug in your first base, which is x, to the highest power 3 to 1 as you reduce it going from left to right. Take your second base, which again includes the sign. So here negative 4 is our second base, and build that down starting at the highest power from the right and move from right to left. So cubed, squared, to the first, to the 0, and then just combine and simplify what you have. So you have your x cubed. You have 3 times the negative 4 is negative 12 for x squared. Negative 4 squared is 16. Okay, so when you're dealing with 16 times 3 is 48x. And then finally negative 4 cubed is negative 64. And that gives you your total answer. Now, there was an alternative way that you can approach this. If this pattern does not make sense to you and you have difficulty working with the pattern, what you may need to do instead is to break this down into something like x minus 4, so one binomial, times the binomial square, and then just distribute. Okay, so if that's the case, you'd first have to expand the square. So we leave the x minus 4 for now. If we expand x minus 4 squared, we get first term squared, double the product of the terms, x times negative 4 doubled is negative 8x, and then the last term squared plus 16. Okay, and then the final steps would be to distribute. So if we distributed the x here, we get an x cubed minus 8x squared plus 16x. Then distribute the negative 4 minus 4x squared plus 32x. And then negative 4 times 16 is negative 64. And so if you combine down your columns, you get x cubed minus 12x squared plus 48x minus 64, which looks exactly like what we got from our pattern. So it's all complete personal preference for you to determine which one you would prefer to use. All right, questions on that? All right. Let me give you one additional problem. All right, see if you can solve this. Applying the properties of the binomial cube. So 3 minus x quantity cubed. See if you can expand that out, please. Right, again, the pattern is you recognize a binomial cube. The coefficient pattern is 1, 3, 3, 1. Start with your first term, which is 3. The highest power, 3. Reduce it by 1 each term. Take our second power, or our second term, which is a negative x in this case, to the highest power 3. Reduce it squared to the first, and then just simplify what you have. So 3 cubed is 27. 3 squared is 9. 9 times 3 is 27 times the negative x gives you negative 27x. The negative x squared gives you a positive x squared. 3 times 3 is 9x squared. And then finally, negative x cubed gives you negative x cubed. And so the one last thing you would need to do here is to write this in standard form. And standard form is highest degree first. So the negative x cubed plus 9x squared minus 27x plus 27 would be the appropriate simplified form.